Hi, welcome back to a new lesson of geography. If you don't know me, my name is Oscar Lemus, and today it's time to talk about the vastness of the solar system. Geography is a multidisciplinary science that integrates knowledge of other sciences around it. To study them, know the facts and phenomena, help from other science is needed. Today we will approach astronomy. Well, there are many things to talk about that I don't know where to start. First, what is the solar system and what makes it so magnificent? It is known as the solar system to the group of bodies like planets, satellites, asteroids, meteorites, and comets that orbit around the sun. The sun is the biggest star. It has a bright yellowish color and is very far from the Earth. They are 150 million kilometers away, and even being so far, the sun is a powerful source of light, heat, and energy. Without the sun, we will not exist and there will be no life on Earth. The sun is made up of 6 layers, each with different characteristics, and their names are core, radioactive zone, convective zone, photosphere, chromosphere, and corona. We will start with the center, that is the core, until we reach the corona. The core is the center of the sun and its temperature is about 50 million degrees Celsius, which produces thermonuclear fusion. The core is the one who generates more energy and is produced in the core powers. The sun produces all the heat and light we receive on Earth. The second layer of the sun is the radioactive zone. In this, the energy of the nucleus lives through radiation, and this energy bounces around the radioactive zone. The energy is radiated in form of gamma and X-rays, and then we have the convective zone. In this third layer, energy is transmitted by convection with a temperature of 2 million Celsius degrees, where large bubbles of hot plasma move upwards. The photosphere is the sun's surface and the visible part of it. Here is where the most of the sun radiation escapes outwards and is detected as the sunlight we observe on Earth. And in the photosphere are some areas with strong magnetic fields which can alter the Earth's magnetic field. Then we have the chromosphere. It is the atmosphere of the sun and it's formed by incandescent gases, and it has a bright red color as shown in the picture. Corona, it is the outermost region and has beautiful silverish white crown around the sun with plasma streaming outside. It can be observed during a total eclipse and the temperature can reach 1,000,000 Celsius degrees. Planets are dual bodies that are capable of reflecting light and revolve around the sun in elliptical orbits. Nowadays, there are 8 planets in the solar system. The rocky planets are Mercury, Venus, Earth, Mars, and the gas giants that are Jupiter, Saturn, Uranus, and Neptune. Let's talk about our planet. The Earth is the third from the Sun, and there are many things to learn about it. Let's start with the structure of the Earth and what is inside the giant sphere. Basically, Earth has 4 layers. The innermost is the nucleus, which is divided into two. The internal nucleus that has a temperature around 5,000 degrees Celsius. It is solid because of the great pressures that the superior layers exert on it, and it's composed mainly of nickel and iron. And then we have the external nucleus, which is liquid and presents ascending and descending convective movements that produce electric currents. What made the energy magnetic field? It's composed mainly of molten iron, nickel, sulfur, and silicon. Then goes the mantle, which is separated from the nucleus and it has 2 zones. The lower mantle, also called internal mantle, is mainly composed of iron silicates and is solid. And the upper mantle or external mantle, it is just below the Earth's crust. It contains solid elements and magma. When magma melts, it is expelled to the Earth surface through volcanic eruptions, cracks, fissures, and is known as lava. The third is the crust, and is the most superficial layer on Earth, and the tiniest one. It is divided into the oceanic crust, which basaltic rocks predominate. The oceanic crust covers the upper mantle and is the seat of the continental cortex, and the continental crust, which is the outermost layer on Earth. Its thickness has 35 kilometers but is greater in the mountain zones. Here, granitic rocks predominate. And finally, the lithosphere. It is Earth's outermost layer and is formed by the crust and the upper mantle. It is formed also by 16 tectonic plates that move about one of the mantle's most fluent zones called asthenosphere. It supports the lithosphere, including the continents, and here is where the volcanic eruptions and earthquakes happen. The lithosphere was broken in big blocks now called tectonic plates, in which we have the Caucasus, North American, Caribbean, and Pacific plates. But what are the consequences of the movement of the tectonic plates? Well, the plates are always moving, causing earthquakes and volcanoes, sometimes affecting buildings and causing deaths. In the surface of Earth exists three main landforms: the mountains, which are the highest elevations of the crust and can be origin when two plates collide. The plateaus are high plains, which are areas of highland with relatively flat terrain, and they are above 500 meters above the mean sea level. And the third landform are the plains, that are zones whose altitude does not exceed 500 meters above the sea level. Have you ever asked how people study Earth and its relation with organisms? Well, 5 methods are used. To locate something, the geographical coordinates and maps are by altitude, longitude, and latitude. The second is the causality, which answers the question how and why does it happen. The relation, which refers to a geographical phenomena and the social and biological events that happen in a place. The generality answers the question where and where does it happen. And the last one, the evolution, answers the question how does the transformation occur. In the rotational movement, the Earth moves around the polar axis following a west to west direction. The duration of this spin lasts 24 hours. Thanks to rotation, we have the day and the night. The Earth pose, and also we have the deviation of the body during free falling, the movements of the stars and the sun, the Coriolis effect, which is the deviation happening to winds and ocean currents, and also the time difference around the globe. Then the Earth's revolutionary movement follows an elliptical orbit around the sun, completed in 365 days, 5 hours and 48 minutes, and it determines the seasons of the year. Other components of the solar system are asteroids, which are rocky bodies that orbit around the sun. They are smaller than planets but bigger than meteorites. Most of asteroids are in the asteroid belt between Mars and Jupiter. Then we have the meteorites, that are little chunks of rock or in space. They are solid bodies that origin from the destruction of comets and asteroids, and that cross the space with big velocity that survive the journey and hit the ground, causing meteorites. The fifth component of the solar system are the comets. They are low-density bodies, basically cosmic snowballs of frozen gases, rock, and dust, roughly the size of a small town. They are formed by a head or nucleus, coma, and the tail. Comets move around the sun in very long elliptical orbits. When they come close to the sun, they heat up and spew dust and gases that make the head to glow. Well, let's talk about satellites. They are small rocky bodies that move around bigger objects like planets. Normally, are moons and move around the planets of the solar system. There are about 146 satellites in the solar system, and there is one in the Earth named Moon. The Moon was the only known satellite, since the astronomers didn't have the necessary instruments to look farther into space in the ancient times until Galileo discovered 4 moons in Jupiter. What about the characteristics of the Earth's moon? Well, first, it is the only natural satellite, which is a sphere composed by heavy chemical elements such as aluminum, calcium, iron, magnesium, silicon, and some others, and it reflects the sunlight. Since there is no atmosphere in the moon, the temperature is very extreme, and gravity is much weaker than on Earth. That's why objects fall faster on Earth than on Moon. Its diameter is 3,476 km and is the 5th biggest satellite of all known in the solar system. It presents a rotational movement around its axis and other revolutionary movements around its gravitational center. Both movements are done simultaneously and synchronously, so only one face of the moon can be seen from Earth, and both loops last 27 days. But what do we mean by the phases of the moon? The moon crosses phases during its movement around the Earth. The phases of the moon are the following: new moon, first quarter, full moon, and last quarter. The first one is the new moon. Here is the moon in the new phase. It is when a new cycle starts, every 29 days. In the new moon, the sun and the moon rise the same day at the same time. Then we have the first quarter. Here the moon appears illuminated on its right side and it's located in relation to the sun 90 degrees. Dawn occurs 6 hours before the moon rise. The full moon is when the sun, the moon, and the earth are directly aligned. The moon looks totally illuminated and there is a 12-hour difference between the moon and sunrise. And the last quarter, which is located 270 degrees considering the sun position. That's why the left half is illuminated and the moon rises 18 hours later than sunrise. But why is important the moon? Well, the moon made the days longer. Before, they last 5 hours and now 24 hours. Without the presence of the moon, the wind will be a hurricane all time, and also thanks to the moon, we have waves in the sea. Going back to the Earth, we are going to talk about the map kinds that we can use. The historical maps represent human bodies. The human maps represent the infrastructure built up by humans. The physical maps represent physical phenomena, and topographical maps are used to locate rivers, towns, cities, and communication means. The fifth is the land use maps that represent the intended use such as agricultural, farmland, residential, or industrial areas. Also, we have the geological maps that represent mine location and rock distribution. The adophological maps that represent the different kind of soil. Then we have the climatological maps that represent the different climates occurring in the regions of the Earth. And the last one is the urban maps that indicate the distribution of streets, suburbs, school, banks, hospital, houses, etc. And for study the Earth, we have also the cartographical projections, which are used to visualize the geographical phenomena and events that the Earth's surface presents. There are different types, thanks to the fact that one has not yet been confirmed, that is the one that exactly represents the Earth in every sense. In this image, you can see some map projections like the globe. Well, that's all for today. I hope you have learned a lot about the solar system and its magnificence. Thanks for watching and see you next week. Bye!